This video is brought to you by Academy of Higher Learning. Hello and welcome to today's physics video on kinematic motion, part 2. In this video, I will be going over the following: speed, velocity, and acceleration. So let's start with the first one, speed. Speed is a scalar and it's basically how fast you're going. Therefore, the equation is v without the vector symbol arrow equals distance over time. Or you can just write down dot. So an example would be, what is the average speed of your car if you traveled from Toronto to London, Ontario in 90 minutes? And the approximate distance is 192 kilometers. So it's basically, since it's distance over time, so let's just first turn this into hours, so it'll be 1.5 hours, and we just sub it into the equation. It'll be 192 over 1.5, which gives us exactly 128 kilometers per hour. And keep in mind, this is average speed. Therefore, you can be going either, well, realistically, you're not going to be going 128 the entire time. You'll sometimes be above it or below it, like you're driving above the average speed. You see a cop, you slow down, then you speed up again. Not that I'm telling you to do that. So next is velocity. Velocity is a vector, and it's the speed of an object in a given direction. So the equation is v, again but this time with the vector symbol, and it's displacement delta d, change in displacement over change in time. And yeah, that's the equation. So the way, it's sometimes hard to distinguish between speed and velocity, but speed, as you can see in this example, like whichever direction it is, you'll just say 2 meters per second, whether it's going right or left. Whereas in velocity, you have, if it's going 2 meters per second to the right, you say it's positive, or if it's going to the left, it's negative. And you have to make a graph, so you can switch these around, but the symbols will switch as well. So here's an example, and it's basically you traveled from your school to your home and then to the racetrack. What is your average speed and your average velocity if it took you 2 minutes to get to your final destination? So the average speed would be, again, so first, before I do that, let's just convert 2 minutes into seconds. So that'll be 2 times 60, which gives us 120 seconds. I'll just put it here. And next, we should assign a coordinate system, because we are looking at velocity. Therefore, let's say anything on the right side, it's left, and anything on the right side, it's right. Or you can do east or west. It's up to you. So next is, we need to find, let's first go for speed. So average speed, which is distance over time, dot, and the distance is 20, then you went 40 to the racetrack. So the total distance is 20 plus 40, which is 60, and the total time is 120 seconds. 60 over 120, and it gives us that the average speed is 0.5 meters per second. Next, yeah, this is in meters. Also, I forgot to tell you that you have to make an origin. In this case, I just made the school the origin, but you can also make the home the origin, and that will make the school 20 and the racetrack 40. It doesn't really matter. So for average velocity, we need to find the displacement, and the displacement is change in position. So basically, it's the change in position would be like it's plus 20 to the right. Therefore, delta d equals 20, the final position minus the initial position, that's 0, over 120, and that gives us 1 over 6, and that is approximately 0.167 meters per second. And you also need to include the direction, so that's, since it's to the right, you have to put that to it there, so it's right. Next is the final thing is acceleration. Acceleration is also a vector and is the rate of change of velocity with respect to time. So the equation would be A equals velocity over time. So here's an example. You accelerate at a constant rate of 2 meters per second for 1 hour. What is your final speed if your initial speed was 30 meters per second? So in this case there is no direction, but we need to find the final speed. So the final speed is going to be v2 equals v1 plus at, the amount you accelerated for. So let's find the at, and the way I got the at is by like bringing t to the other side, and this is v2. So at would be, so this part would be equals 2 times 1 hour. Let's do, that'll be 60 minutes. I mean no, that'll be 3600 seconds, and yeah, so that'll give us 7200. And since our initial was 30 meters per second, just put that in here. So it'll be 30 plus 7200, and that will give us 7230, which is ridiculously fast meters per second. And that's pretty much it. That's the end of